PARRISE team developed a socio-scientific inquiry-based learning framework for science teaching. The pillars of this method are the SSE, socio-scientific issues, the citizenship education, and the inquiry-based science education, IBSE. The umbrella of the whole program you can see on this picture as the outermost shell. This is the responsible research and innovation. The core of the program is the SSE, socially scientific issues, and the inquiry-based science education. We adopted this method, this framework, to the Hungarian physics teaching traditions and fitted it to the national base curriculum. The core of our program is the responsibility. Our main educational goal is to develop in students the feeling of responsibility. However, the feeling of responsibility is a property of our brain, is a mental property, and in itself it's not enough to make good decisions. To make good decisions, we should teach our students to critical thinking. Critical thinking means in this context that they can balance the controversial arguments concerning the scientific innovations and scientific research, and they should thinking independently from manipulations of television and press. It needs a deep knowledge on the debated questions, on the questions of environment and so on. And it should a deep knowledge, the deep understanding of the concept with which we can describe the scientific results. When we discuss this, when we train our students to critical thinking, then we should discuss questions which are in the front of the interest of the society. These questions are the environmental questions, the questions of energy sources, the renewable energies, the questions of nuclear energy, the climate changes, and so on. I would like to illustrate with some examples what we mean by critical thinking and deep knowledge in this context. The story comes from the time of the accident of Chernobyl and was written by George Marks. George Marks was a theoretical physics professor of the ELTE, and he was the expert of nuclear physics. Some days after the accident, the Hungarian television announced that a radioactive cloud had reached our country. In the morning of this day, students of a grammar school queued before a physics laboratory and waited their teacher and claimed to repeat the background activity measurement. They experienced that the background activity was 3 times higher than before. Then they opened the window to let in the Chernobyl activity and measured again the background. It was very surprising that the background activity fell down almost to its old value. It was an unforgettable lesson for the students because they learned that the prejudice connected with the scientific results and scientific facts can be eliminated with measurements and the exact and cautious treat of the facts concerning these problems. The other issue, in the atmosphere there are tropical cyclones and mid-latitude cyclones. These are big spiraling air masses, and the air masses is spiraling around low pressure center. To understand the spinning of these formations, it needs the deep understanding of the concept of Coriolis force. Coriolis force is one of the biggest challenge of the physics didactics. Here is the core of this problem. The rotating observer and the resting observer observe different paths, for example, a flying bird. However, there are smaller eddies in the atmosphere. This is a dust devil. Here is an artificial fire tornado, which was demonstrated in the garden of the National Museum. And here is a water spout, and here is the well-known tornado. These eddies are smaller than the tropical and Mediterranean cyclones, and it's very strange that in the control of their spinning, the Coriolis force can be neglected. The funnel is the characteristic feature of this phenomena. If we look through the steps of the teaching of these problems, is the following: the observation, the experiments, construction of models, mathematical description, and explanation of these effects. In inquiry-based learning models, it's very important that students should make their own experiments. We have a laboratory, the Carmen laboratory, where students can make model experiments connected with tornadoes, and here you can see the funnel of a model tornado. The funnel is made visible by a drop of paint.
In 2015, the Graduate School for Physics, together with the Hungarian PARRISE team, organized a conference teaching physics innovatively. It contained a wide variety of topics, from inquiry-based science education to socially sensitive issues, nuclear issues, etc. The conference has more than 100 participants from 18 countries. It has 60 contributing speakers. Most of them was in-service physics teachers or teacher educators. We have 10 keynote speakers. For example, Marisa Michelini from GIREP, David Featonby from Science on Stage Europe, and Hannu Salmi from the External Advisory Board of PARRISE. The last event of the conference was a roundtable discussion on socially sensitive issues. The main subject was nuclear energy. After the official program, we organized an optional excursion to Paks, a single nuclear power plant of Hungary. Participants could visit the maintenance and training center of the nuclear power plant, which was a good opportunity for informal learning. The proceedings of the conference now is available from our website. You can download freely the whole conference book or the papers separately, or even the slides of contributing speakers. And there is also a discussion forum associated with each paper. In November of this year, with the help of the Hungarian Academy of Sciences, we managed to print the book, and now it's available for interested physics teachers.
It was a great challenge for my students and me, and I think it was an enjoyable and effective way of learning, as the students were active participants of the project. During the project, a lot of skills were developed, such as communication skills and collaboration skills, and of course critical thinking and problem-solving skills. During the project, they learn how to gather information from provided sources and how to analyze them and how to make consequences and how to share their ideas about the topic with the rest of the class. Most of the time they worked individually. They made inquiry-based research work And after that, they made presentations and shared the results with the rest of the class. And I think the most important goals were that they became motivated and they enjoyed all the lessons, and they became they improved their awareness of environmental issues, and we could discuss social and science problems at the same time. We could integrate other subjects into physics lessons such as biology and geography, and of course they enjoyed it very much.